Welcome to AI Podcast. I'm Ethan.
And I'm Maya. Today we're talking about InfantAgent Next from NeurIPS 2025. Quick headline first.
In a sentence, it's a modular generalist agent that uses a computer like a careful power user by routing each step to the right specialist. It beats strong baselines on desktop tasks, holds its own on coding benchmarks, and does well on a general assistant test.
Nice. Who's behind it?
Lead author Bin Lei with collaborators including Mingyi Hong and a larger university and industry team.
Got it. So what problem are they trying to solve exactly?
Right now, computer use agents tend to split into two camps. One camp is tool-heavy, great at things like running code or searching the web, but clumsy at clicking around real apps. The other camp is pure vision, decent at pointing and clicking, but they struggle when the job really calls for structured tools. Both miss the mark in everyday workflows.
So either they can type in code but can't hit the right button, or they can click everywhere but reinvent the wheel for a simple file edit.
Exactly. And the pain points are very human-sounding. Misplaced clicks, off-by-one-line edits, overwriting the wrong block of text. The paper's gap is simple. Make one agent that can plan, choose the right tool, and precisely act on a real desktop.
What's their big idea to close that gap?
Modularize. Think conductor and section leads. A planner figures out what to do next. A tool selector decides whether this is a job for browsing, code execution, file editing, or direct mouse and keyboard. Then an executor carries out the step. Around that, you've got specialist perception modules for vision, audio, and video.
So instead of one omniscient model doing everything, it's a team of models with clear roles.
Exactly. And they share a single conversation memory so context doesn't get lost. The memory is organized with typed tags like labeling a line thought or task or which toolkit to use, so each module only sees what it needs.
I like that. It's like color-coded sticky notes for the agent's brain.
Perfect analogy. They also inject only the relevant tool instructions at each step, so the prompts don't balloon with irrelevant docs.
What about the tricky parts, like clicking tiny UI elements?
They add a neat refinement loop. Imagine trying to tap a tiny icon on a crowded phone screen. You zoom in, center it, and try again. InfantAgent Next does the same by iteratively cropping around the target region to sharpen the click location.
And for file edits, which are famously brittle?
They avoid risky search and replace by drafting an edit plan, verifying it, and using safer matching if line numbers shift. It's like a surgeon mapping the incision before making a cut.
Love the imagery. Where did they test this thing?
3 fronts. First, OS World, which is a suite of real desktop tasks. Second, SWE Bench, a software engineering benchmark with real GitHub issues. Third, Gaia, a general assistant evaluation with mixed modalities.
Let's unpack each one. OS World first. What did they compare against?
They compared against strong computer use baselines, including Claude's computer use system. For fairness, they actually turned off some non-visual toolkits, so it was closer to a pure desktop control setting.
Interesting choice. So the hybrid system had to play by vision-centric rules there.
Right. And they report improving over Claude computer use. There's a small discrepancy between versions of the write-up. One says 7.27% accuracy, another says a 7.27-point gain. Either way, the message is that their approach is competitive on real desktops.
Okay, SWE Bench, that's the coding one. How did they run that?
They looked at 2 slices. A small verified subset, where they hit roughly 2/3 accuracy, and a lighter set, where performance was around 1/3. The key is that their guarded file edit procedure plus modular planning seems to help on real patches.
And on Gaia, the general assistant benchmark?
They report ranking second among open-source agents overall and leading on mid-level tasks at their evaluation time. The hypothesis is that the router plus specialist design gives them flexibility across modalities.
Now, under the hood, did they rely on closed models?
Some, yes. For reasoning and planning, they used strong proprietary models like Claude or GPT-4o in different settings, and a vision model to ground UI elements. That's common today, but it does raise reproducibility and cost questions.
Right, if the vendor updates the model quietly next month, numbers can shift.
Exactly. The team does share code and evaluation scripts, but exact replication still depends on those model endpoints. They also run everything in an isolated virtual desktop, so the agent can control a machine safely without touching the host.
Good ops hygiene. Were there any choices in the experiments that gave you pause?
A few. On OS World, they disabled some toolkits for fairness, which makes sense for comparison but doesn't show the full hybrid power. On SWE Bench, Verified, they reported results on a 50-case subset, which is transparent but smaller than the full set, so sampling matters.
So, promising signals, but you'd like to see the complete hybrid system turned loose on OS World and the full verified split on SWE Bench.
Exactly. Plus stress tests, different screen resolutions, high latency, dark mode, accessibility settings. Real users live in all those edge cases.
Let's step back to the architecture for a second. Why do you think the modular approach helps in practice?
2 reasons. First, separation of concerns reduces compounding errors. The planner doesn't need to hallucinate how a tool works because the tool selector consults actual tool specs. Second, specialists can be swapped. If a better vision model comes along, you can upgrade just that piece.
Like replacing the lens on a camera without throwing out the body.
Exactly. And the shared memory means the story of the task persists across modules, so decisions remain consistent.
Any parts you'd call especially clever?
The click refinement loop is simple but pragmatic. Also the edit guardrails. Those 2 target real failure modes that frustrate users.
What do the authors say about limitations and next steps?
They acknowledge that much of today's tool use is still prompt engineered. Their plan is to train models to invoke tools automatically, so the system learns when and how to pick the right instrument rather than being coached step by step.
So the future is less scripted, more learned.
Exactly. I'd add 2 more directions. 1, more runs with fully open-weight models for planner, selector, and executor to lower cost and improve reproducibility. 2, evaluations that push the hybrid stack in its natural setting with both tools and GUI enabled, not just one or the other.
And maybe broader safety and governance, like permission prompts and audit logs of which tools were used and why.
Yes, and ablations that quantify what each module buys you. How much do the memory tags help? How much does tooldoc selection reduce mistakes or cost?
Before we wrap, can you give me a human-friendly analogy for the whole system?
Picture a Swiss Army knife, but each blade is a master craftsperson you can call on demand. The planner says, "We need the woodworker." The tool selector dials them in, and the executor hands them the workbench. When it's time to click a tiny icon, the vision specialist hands over a magnifying glass. When it's time to edit code, the careful scribe lays out the plan before changing a line.
That is wonderfully nerdy, and I am here for it. Final takeaway?
InfantAgent Next shows that a thoughtful division of labor can make computer use agents both more precise and more adaptable. The early results across desktops, code, and general tasks are encouraging, with some caveats about closed models and evaluation scope. If they follow through on learned tool use and broader open evaluations, this could be a template many teams adopt.
Nicely put. For folks building real assistants, the message is clear. Don't make one model do everything. Give it a team, give it memory, and teach it to pick the right tool for the moment.
This has been AI Podcast. I'm Ethan.
And I'm Maya. Thanks for listening, and we'll see you next time.